Hi, and welcome to the Soil Health Connection. I'm Sarah Light, Agronomy Advisor with the University of California Cooperative Extension, and I'm here with my co-host, Liz Harper, the Executive Director of the Colusa Resource Conservation District. Today, we're interviewing Dr. Claire Phillips. Claire is a research soil scientist at the USDA Agricultural Research Service based in Ames, Iowa. She actually is our first guest from this branch of the USDA. It's really a pleasure for me to have Claire on the show today. I've known her for many years, actually since before I was a soil scientist, and she gave me this shirt. We used to work together on a biochar project at the USDA in Corvallis, Oregon, and the Pacific Northwest Biochar Atlas was created as a part of that work. I highly recommend anyone interested in biochar visit that site to get more information. Claire, you collected a great amount of data over the years on biochar's impact across many soil types, climates, and land use systems, including both natural and managed lands. Soil health is the intersection between soil physical, chemical, and biological processes. And biochar actually has the opportunity to impact all three. Can you start by telling us how biochar influences soil physical composition and structure when applied to our cropping systems?
Sure. And, I just wanted to first take a step back before we get into talking about more of the technical aspects about what biochar does, to just acknowledge that sometimes research is research because, applying charcoal as a soil amendment is an idea that's been around in soil science and in agriculture for a long time. And biochar, calling it biochar, and this kind of iteration of looking at charcoal really came out of work that was done in the Amazons looking at terra preta soil, and Johannes Lehmann at Cornell was really instrumental in kind of bringing that lesson of the terra preta soils to the rest of the world. And of course, it really makes an impact when you see the picture. So let me just share with you guys. Here we go. Let me scroll up. So this is a picture that I'm sure a lot of people have seen. This is a tropical oxazole soil, typically weathered, right? And here's a terra preta soil that had additions of organic matter, including charcoal and manure and other materials that improve the fertility. And some of these terra preta soils radiocarbon date to century or millennia ago. So they continue to be very fertile, productive soils even after a really long time. And so there's this open question of, can we recreate these qualities in the temperate regions in our agricultural soils here by adding charcoal, among other things? You asked about the physical properties, and I want to kind of show you some pictures of biochar. So this is one project I was fortunate to be involved in Washington State, where this was a producer who had a seed cleaning mill and had all this extra straw and actually built a gasifier on farm. And here's what his grass straw and grass seed biochar looked like, and was using it on farm too. So that's another element about biochar that sometimes gets glossed over, is that there's really great opportunities to pair low value biomass that we need to get rid of with applying it into agricultural soils that could really benefit from it. And so this is showing the experimental plots where we applied it to his farm. This biochar too, here I'm just putting a little droplet of water on it, and you can see the biochar clinging to the water droplet. So this biochar is really hydrophilic. It's not always the case. Some of these biochars have more waxiness and hydrophobic qualities to it, but especially biochars that are made at high temperatures can be really hydrophilic. And we know they have a good amount of internal porosity. And what we found in our research, and the research that Sarah was involved in, is that they create a lot of pore structure between soil particles and between the biochar particles too. So biochar is very low density, has this internal pore space, helps create external pores too, And so it really increases the bulk density of the soil, which is an important soil health indicator. We did a lot of research on whether it can improve soil water retention. I have a picture of Sarah out in the field here, incorporating biochar, right? So we incorporated biochar into experimental stations across Oregon. I've drawn a box around these two where we had soil moisture sensors. So the water impacts of biochar we found were pretty complicated. Even when the biochars themselves hold a lot of water inside that internal pore space, when you put them in soil, they can increase drainage quite a lot. And so I've got these time series figures here where these are buried soil moisture sensors. And the darker the color, the more the biochar was in the treatment. And so in this loam soil from Central Oregon, the biochar made the soil drain quite quickly, and the biochar plots had a lower water content over time. Whereas in the sandy soil, we didn't see that. We didn't see any effect of biochar. So one thing that I've learned from biochar research is complicated. It's not a panacea. It doesn't fix everything. And I would say it's different from uncharred organic matter in that way, right? Where uncharred organic matter can have this whole host of soil health benefits, improving the structure, providing nutrients, increasing microbial abundance, and affecting the composition. Biochar, depending on what it's made from and the temperature conditions it's produced under, it can be fairly inert. It can have to be added in very large quantities to have some nutrient benefits. So I'll stop there and see if you guys have more questions for me.
Yeah, so to kind of keep this conversation going on biochar's influences on soil, how does it impact soil chemistry?
Yeah. And so there it really depends on the kind of biochar. So you need to think of it in terms of these are biochars. So you can make biochar from wood, but you can also make it from residential yard waste or from poultry litter manure. And the chemistry profiles of those are really going to differ considerably. And there's a temperature effect too. So the higher the temperature, the more you're burning off some elements, but you're also getting more ash. So one thing that was really striking in the research we did is in really acidified agroecosystems, we saw more yield benefit. And I think that was probably largely a liming effect. So when you have high temperature biochars, they have a lot of ash in them, it acts like a liming agent. But that's not necessarily the only way the biochar is having an effect. So there's, and one example of that is some of the research at Oregon State was looking at blueberries. Well, blueberries really thrive in acidic soils. And biochar additions to acidic soils, it didn't raise the pH enough to make it outside the range that blueberries liked, but it still improved blueberry production. Mm-hmm. So there's one idea out there that that increasing the pH makes the soil environment more hospitable for microbes that are involved in nitrogen cycling, nitrifiers, so microbes that convert ammonia to nitrate. So I think that's a really interesting idea of a way that biochar may be improving nitrogen cycling. And another way it affects soil chemistry, biochar, we think of activated carbon as something that's really good at tying up pollutants. Biochar is very effective at tying up some organic pollutants, tying up some pesticides, and heavy metals. very good. Some of the biochars we've looked at in heavy metal affected soils, you know, we showed that you were able to grow plants in mine tailings that are just amended with biochar. You know, and part of that is the pH effect, and part of it's the fact that biochar is tying up heavy metals.
All right, I'm going to keep you going. So, how about soil biology? How does biochar influence biological indicators?
Yeah, you know, I mentioned that it's changing the pH, it's changing, so there's indirect effects on microbes, right? Because biochar will change the soil environment. Biochar itself is very high in carbon relative to nitrogen. And so in some studies, the shift in the microbial community is more towards fungi, which are a bit more capable of breaking down carbon. There's really interesting effects on, it's called electron shuttling, right? So a lot of the reactions, say in nitrogen cycling, involve oxidation reduction reactions. Biochar can act as an electron donor or an electron receiver. And one thing that biochar appears to be very effective at is reducing N2O emissions. And N2O is a greenhouse gas. And we think that's because biochar helps shuttle electrons in as nitrate gets converted to N2O, it helps the complete conversion all the way to N2. So yeah, some really interesting chemistry going on that affects the nitrogen cycling processes that microbes are involved in. And the other way that biochar is changing the environment in which microbes live in is the pore space. It creates more pore space that can mean better aeration, and it can also mean, in some cases, more moisture. So, yeah, I mean, I will say that there's been some descriptions of biochar as like a hotel for microbes. You know, one thing to keep in mind is that biochar itself is not a great microbial food source. It's full of carbon that is very persistent and not very available to microbes. And so I don't really agree with that characterization that biochar is great for microbes. I see a lot of kind of biochar early adopters that are adding things like molasses or compost, more microbially available carbon with their biochar. And they're using biochar with a suite of soil health promoting practices. And so I think that's important to keep in mind, that biochar can be used well as an ingredient with other sources of nutrients, with other sources of available carbon that are going to stimulate microbes. And that's a good approach to take.
Yeah, I feel like I could just be saying wow after every sentence you say. It's very, I'm learning so much about biochar in a different way than, you hear about it at like the farm show or just general information. So you kind of were leading into this, but your research has led you to look critically at the use of biochar and its usefulness in cropping systems. So how do you recommend using biochar in agronomic decision making? And what is the ideal use for it? And when should you be spending dollars on other soil practices?
That's a great question. I think I mentioned a few of the situations where I think biochar really shines. Heavy metal affected soils, where situations where there is an organic pollutant or, some really persistent pesticide. We know that charcoal is really good at tying up those things. High value cropping systems where you really need to build up the soil and build it up quickly. I think biochar is great as a bulking agent there to try and get some structure into the soil quickly. I think it can be used well in combination, as I said, with other sources of organic matter and nutrients, at trying to get more, more structure, more carbon into the soil quickly. So that it's probably cost prohibitive to be using it on field crops, lower value, higher acreage crops. But in intensively managed vegetable systems or vineyards, where it's smaller acreage, it certainly would be a good use of biochar. I think it's important too to recognize those opportunities where there's a local feedstock, and keep all those materials local. Biochar is often touted for carbon sequestration value, and there's really compelling evidence from life cycle analysis that biochar can sequester carbon. But that means too that it can't be transported across the country or even across the state, and still have that carbon sequestration value, right? Because there's an emissions associated with transport. So keeping the material local. We've worked with restoration folks, like Soil and Water Conservation District folks who are looking at water quality. I mentioned some of what biochar does with nitrogen. It looks like it can tie up nitrates pretty well and is really useful for like edge of field buffers and bioreactors and that kind of thing. Is a great use of biochar as like a retention media. And yeah, there's a lot of potential uses of biochar. Co-composting is another really promising area where I've just seen really compelling data where adding biochar early in the composting process, you end up with a material that actually has more nitrogen than if you hadn't put the biochar in. So it appears that biochar is kind of effective at preventing nitrogen loss from ammonia volatilization and nitrate leaching and keeping it in the compost. And people report a better finished compost product. So a whole array of potential uses. I think my research showed that you can't just expect to put it out on a field and have it change anything. But you can make educated decisions about, situations where you need to tie up nitrogen, you need to tie up heavy metals, you need to tie up pesticides. You can look at choosing a biochar that has properties that are really good for that. And that's why we made this Pacific Northwest Biochar Atlas that Sarah mentioned, that it has a decision support tool to try and help producers hone in on what their needs are that might be improved with biochar, and then find a biochar that has properties appropriate for that use.
Thanks so much, Claire. Before we wrap up, can you tell us about your current research on biochar and how our audience can find out more information about that work?
Sure. I'm mostly finishing up projects from Oregon, and all that work's going to be mentioned on the Pacific Northwest Biochar Atlas. And yeah, I'm working in Iowa now, and I don't have any active biochar projects going on out there, but I think biochar is here to stay, and I think people are going to become more sophisticated users of it. So yeah, stay tuned.
Great. Thank you so much for being on our show. See you next time.